All right, guys. Hope everyone is feeling healthy. You're watching a short video here for our last polar shape called a lemniscate. It's the Greek word for ribbon. I'll show you the standard form here for a second, but the number one characteristic of a lemniscate is you have this r squared out front, and you're always going to have a 2 theta there. So it kind of looks like a rose, except for the r squared out front, okay? So let's go ahead and start just plugging in some thetas in. It's not too tricky to plug these in. The one thing you got to remember here is that you're trying to plug thetas in right there. So the easiest way to do that would be to get r by itself, which would require square rooting both sides. If you do that, remember you get a plus or minus out front, square root of 3 sine of 2 theta. So this is what you want to type into your calculator, not the plus or minus, but the square root of 3 sine of 2 theta. And what's nice about this is when you plug that in, you actually get 2 points for the price of 1 because you get a plus and a minus. So if you have your calculator, go ahead and start typing these in. We'll do these 4 theta values. And remember, you see the plus or minuses there. You get 2 for each one. So just take a second, make sure you can plug those thetas in to this black equation here, the square root of 3 sine of 2 theta, and make sure you can see those r values. You can pause the video if you need. Once you make sure you can get those in the calculator, if we graph it, you'll see what the shape of a lemniscate looks like. Rotate to pi over 6 and then go out 1.6. That's the positive direction. Negative direction is that way. So there's a positive r and a negative r. If I rotate to pi over 4, I go out 1.7 and then I go negative 1.7. And then the next point is pi over 3, 1.6, and negative 1.6. You can see what we have here is a propeller-shaped curve. So the lemniscates are characterized by this propeller shape. They kind of look like roses with just 2 petals. All right. So try to make that as symmetric as you can. Mine is decent there. It's hard to do right in with this iPad pen. So that is a lemniscate. Now this is a sine lemniscate. You can see how it has that diagonal shape. When we talk about the symmetry here, which we will still list, again, the tests for this aren't so important. Just make sure you can look back at the end and tell the symmetry. This symmetry here, this guy is symmetric to the pole. Remember, the pole symmetry looks like the old origin symmetry, where if you do a double fold over the old y-axis and the old x-axis, you get the shape to line up on itself. Okay, so lemniscates are characterized by these 2 forms. Okay, the key again is that r squared out front. When you see that, you're going to have a lemniscate. And it's always going to be a propeller shape. The one we just saw was a sine lemniscate, right? 3 sine of 2 theta was the original equation. And we had this kind of diagonal propeller shape. That shape will be the same for every sine lemniscate, okay? So let's take a look at the cosine lemniscate, and this is the second kind. There's less variety here than there were with roses. You're only going to have propeller shapes, so kind of a rose with 2 petals. Again, I know this is a lemniscate because they are squared. Here are the thetas I want you to plug in. So take a second, make sure you can plug these thetas in. Again, to get this easy to plug in, we're going to square root both sides. You get r equals plus or minus the square root 4 cosine of 2 theta. That's what you're plugging into the calculator. This square root 4 cosine of 2 theta. You're going to plug that in for these thetas here. So take a second on the calc, make sure you can get these. Remember to include the plus or minus because you get 2 points for the price of 1. Okay, now that you can plug those into the calculator, if I graph those, here's the first point, rotate to angle 0, I go positive 2 and negative 2. Rotate to pi over 6, I go positive 1.4 and also negative 1.4. 5 pi over 6 was the next point I plugged in. If I plug in 5 pi over 6, I get positive 1.4 and negative 1.4. You can see some symmetry happening here. And if you plug in pi over 4, you're undefined. That's okay. You're also going to have a point here at the pole. So what you're going to get is this propeller shape again, just like the sine lemniscate. The only difference is this lemniscate is symmetric to a lot more things. Let me finish it here and I'll show you. Again, try to make them the same shape. symmetric as possible. So the symmetry for this cosine lemniscate, okay, is symmetric to the polar axis. If you fold it in half over the polar axis, it lines up. It's symmetric to the theta equals pi over 2 line, and it's also symmetric to the pole. All right. So that is what a cosine lemniscate looks like. Ribbon shape, symmetric to everything. Just to go back, the sine lemniscate looks like that, ribbon shape, only symmetric to the pole. And those are the only two variations for lemniscates. Sine lemniscate there, and a cosine lemniscate there. Not as many variations as roses. So you'll see one or two of these on the review, and that's it. Remember, you're going to have an assessment on Wednesday that will be on My Math Lab, just like a homework assignment. But when I put it in, it will go in as a assessment grade. So you can use your purple sheets. You can use notes. Just do the best you can. And remember to wash your hands and stay healthy. Email me.